regarding three lessons: estimating area, left endpoint, right endpoint, midpoint, definite integral, we have bounded start and end, fundamental theorem of calculus, we have the application part 1 and part 2. So I will start solving first for estimating area, question number 1 and question number 2. Okay, by using midpoint rule, 8 subintervals, so n equal 8. Approximate the integral. The start and end point are a and b. A equal 2, b equal 4. So the first things all the time we should find it delta x. Delta x is mean b minus a divide n. So b for a2, so the answer will be 2, 4 minus 2, dividing 8, which mean 1 over 4. So see with me, my interval will be starting with 2, finish with 4. Every time we add 1 over 4 or 0.25, so 2.25, this equal 0.25 by calculator. This will be 2.5, this will be 2.75, this will be 3.25. We need more space. So we can do this 3.5, 3.75, and 4. Different color, we say here midpoint. That's mean my point will be lying here and 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 here. Okay. So how we find area? Because here we approximating the area. Or approximating the integration means the area. The integration from 2 to 4 e to the power x squared plus 1 dx equal delta x, which is this one, time f of x1 star plus f of x2 star plus f of x3 star. I'm not going to write all of them till the last one will be f of x8 because n equal 8 star. Why we write x star? Because if we use left endpoint, we will take this point. Right, we will use this one. But here midpoint, the point in the middle. And that's why we write x1 star. So here I can find x1 star equal 2 plus 2.25 divide 2. So it's the middle between this point and this point. So delta x is what? Delta x. We write it where, 0.25. F of the point between this and this will be 2.125 plus f of between this and this will be 2. It seemed like 375 plus f of now between this and this. I'm not going to find all of them. 2.625 plus etc. The last one of them would be f of between this and this 3.75 plus 4 3.825, I think. Then what's happened here? Okay, then you can find this amount, this f. By the way, from here, f of x, the function is e to the power x squared plus 1. This is the function. Catch the calculator, put 0.25, and here you should put e to the power 2.125 squared plus 1, e to the power 375 squared plus 1. Keep till the last E will be E 3.825 square plus 1. Then you can write the final answer here. I'm not going to find it. Just take a time, and I want to make this as short as possible. Almost the same things here. We have Rn or right endpoint. We will not use the midpoint now, right endpoint. So my interval this time it's from where to where, 0 to 1. So delta x equal b minus a divide n, delta x equal 1 minus 0 divide n. The value of n here it's a 5, so this will be 0.2. So this will be 0.2 plus 2 will be 0.4, then 0.6, then 0.8. So area or this integration from 0 to 1 under the root x squared plus x plus 1 equal delta x f of x naught plus on the right. They said the right f of x1, sorry. With left we start with f of x naught. x1, f of x2, f of x3, f of x4, f of x5. This will be delta x from here 0.2. From here you see this is my interval. We say to right endpoint, so this is the right point. For this interval, this is the right point. For this interval, this is the right point. So we will start with f of 0.2, then f of 0.4, then f of 0.6. We complete, by the way. Then f of 0.8, then the last one will be f of 1. So you see here colors. This one, this one, this one, this one will be the right point. Here, this one, this one, this one, this one, and this one will be the left endpoint. And between them, here, let me say here, 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 here will be the midpoint. Okay, so what we will do it now, catch your calculator again. I'm not going to do that. You will do that by yourself. 0.2, and here under the root, 0.2 square plus 0.2 plus 1. Under the root, 0.4 square plus 0.2, 0.4, sorry, plus 1. Plus under the root, 0.6 square plus 0.6 plus 1. One more root, two more, by the way. 0.8 square plus 0.8 plus 1. The last root will be 1 square plus 1 plus 1. Find all these, but here we say for decimal, make your answer here 1, 2, 3, 4. Until in the previous question, we say here for decimal, so I think we should, or I should write it, or you can write the answer here, dot, oh, sorry. 1, 2, 3, 4 decimals. Okay, another idea we have it now, fundamental theorem of calculus part 1, by the way, different color. For the fundamental theorem of calculus part 1, say the integration from a to x f of t dt equal f of x. So if I have x here, t here only, we find the function out, the derivative, sorry, d over dx of this, it's equal the function. So the question here will be find the derivative of the following. So we need to find f prime of x. Here I have x plus 1, here I have function up, function down. We take, if I have f of 1, f of 2, g of t, dt, d over dx, the derivative of it will be what? We say g f of 2 times f2 prime minus g f of 1 times f of 1 prime. So we can apply it direct, no need to make it long and spend time. Direct, we say tan. Inside the tan t, the t we replace it with the function 3x time the derivative of this function, because it's a chain rule, 2x plus 3 minus from the formula. Now we substitute this in the tan again. So tan, inside the tan, we write x plus 1 times the derivative of x plus 1, it's a 1. Same things, we will apply it again here, but here it's a little bit harder, the question. Here only find the derivative, here we have multiplication. So since we have multiplication, it's a product rule. First derivative second, second derivative of first. Okay, f prime of x first, e to the power x. Derivative of this one, 1, open brackets, 1 divide 1 plus e square, it's a cosine x and square times the derivative of cosine. What's the derivative of cosine? Minus sine x negative. We're still finding the derivative of this. 1 divide 1 plus sine square x times the derivative of sine is a cosine. First derivative of second plus second. The second one will be all this integration. Sine x cosine x, 1 divide 1 plus t square dt. Multiplication first, derivative second, second derivative of first. What's the derivative of e to the power x? It's e to the power x itself. So we can rewrite this because I have e to the power x here, e to the power x here. I can take it outside. 1 e to the power x time minus sine x divide 1 plus cosine square x minus cosine x divide 1 plus sine square x plus the integration sine x cosine x 1 divide 1 plus t square dt. Close it. This ex, this e takes, I take it as a common, so that's why here negative, here positive. Okay, fundamental theorem of calculus again, but this part 2 where we should find this. You can check your answer by calculator, but I write here without calculator. Don't use the calculator. Different color again. So the integration or antiderivative of this will be x to the power 3 divided 3 minus 4x to the power 2 divided 2 plus 4x from 0 to 3, which means x to the power 3 divided 3 minus 2x squared plus 4x from 0 to 3. And I remember in the class, the students hate this type of brackets. They prefer this type. It's fine, you can use any type of brackets. The answer will be the same. Okay, so substitute 3 here. 3 times 3 times 3, 9. 27 divided 3, 9. 3 times 3, 9. 9 times 2 minus 18. 3 here will be 12. I substitute the 3 here. Now substitute 0 here will be 0. Substitute 0 here, 0, 0. 0 minus 0 plus 0. All of it. So 12 plus 9, 21. Minus 18. And 21 minus 18 equal to 3. Okay, let me check this again. X to the power 3 divided 3, 4x squared divided 2 plus 4x. We substitute 3, 9. Then substitute 3 minus 18. Then substitute 3, 4 times 3, it's a 12. So I believe the answer is correct answer. You can check this by calculator. I don't have time to do that as usual. Let us move now to the next question. Let me do it by calculator to be 100% sure. So this is 0. The upper is 3. Yeah, I think it's a correct answer. Okay, here, the antiderivative of this will be ln x plus the antiderivative of this will be 1. Again, okay, it's better if I write it in this way. From 1 to e plus another integration, 2 different integration, by the way, here. 1, oh, I think yes, 1 to 4, and divide this, separate it to be 2 root of x divide root of x plus x divide root of x plus 3 divide root of x. So this one will be 2 plus this one will be root of x, this one x to the power half, raise it up will be minus half, x to the power minus half. And until this one, to make it root to the power half direct, it's easier to find it. So substitute e here and what I write here, x, I write 1. Len e is a 1 plus e minus substitute 1 here, 0. Len 1 is a 0 minus plus 1, sorry, minus. So 1 minus 1 plus e, the final answer will be e to the power 1 and plus. For this one, the integration 2x plus x to the power 3 over 2, 2 over 3. This will be x minus half plus 1 will be half, and 2 over 1 from 1 to 4. Substitute 4 here, it's an 8. Substitute 4 here, 2 to the power 3, 8, 16. Divide 3 plus substitute 4 here, the root of 4, 2 times 2, 4. Minus, don't forget, all these will be. Substitute 1 here, 2, oh, this time the brackets come on. Substitute 1 here, 2 over 3. Substitute 1 here, 2. 8 plus 2, it's 12. So e plus this with this give me 12 plus 16 over 3. This would be 4, so minus 4. And minus 2 over 3. So 8, this and this will be 8, e plus 8. Now plus 14 over 3. This will be the final answer. You can simplify it by calculator, I think, but you can make this 13 to make it one number, but still e. Okay, so the first idea was estimating by use left endpoint, right endpoint, midpoint. The second idea we have it here was fundamental theorem of calculus part 1. This question now with bounded, it's definite integral here, sorry. And now application of definite integral and the fundamental theorem of calculus part 2 question. A particle is moving along a line so that the velocity at time, we know that we have displacement and derivative d over dt per time will give me what? Will give me velocity. And now we have velocity, find the displacement. So it seems like we're going back. How we go back? By integration. So displacement s of t equal the integration of v of e dt, and it's equal the integration. The function here is tan square 2t minus cosine 3t, all of it dt, and we have period or yes during this interval, which means pi over 0 here, sorry, the start point, and pi over 4 here. S of t. You can use the calculator direct, but we don't like to do that. how we can find it without calculator? Sine square plus cosine square equal 1. We need the tan sine over cosine square, cosine square, cosine square. Sine over cosine, it's a tan square plus 1 equal secant square. So I have the tan, so the tan equal what? Tan square. 1 secant square minus 1. So we come here, write 0 pi over 4 and replace this amount with what? Secant square 2t minus 1 minus cosine 3t. Find the antiderivative of secant square, the derivative of tan secant square. So tan 2t, don't forget to divide on 2, minus t minus sine 3t divided 3. 0 to pi over 4, so tan, because 2 pi over 2, all divide 2, minus pi over 4, minus sine 3 pi over 4, all over 3, all this result minus tan 0, 0, by the way, tan 0, 0, minus 0, sine 0, it's 0. So this amount only will be the final answer. You can find this and this and this by calculator of the final answer here. Again, I want to make this short as much as possible. The last question in this video will be almost the same thing. We have the velocity, and you know that at time t, this initial value, the position was x equal 4. So v of 0 equal, no, not v, the position, it's mean, sorry, s of t equal 4. What's the position of the particle? 5 seconds. So we need to find s of 5. This is what we need to find. Find s of 5. So we have v of t, and the integration of it will be s of t, by the way. So dt. So s of t equal the integration 2t square minus under the root t plus 1 dt. We don't have interval here, so that's why we need to find the antiderivative here. The antiderivative of this will be 2t to the power 3 divided 3 minus, this will be t plus 1, by the way, t plus 1 to the power half. So this will be t plus 1 to the power 3 over 2, 3 over 2, or I hate to write it like this, 3 over 2, I prefer 2 over 3 outside here, plus the integration of 1t plus c, s of t. We have s of 0 equal to, this 0 will be 0. Substitute 0 here will be 1, 1 to the power 1 times this minus 2 over 3, plus t is a 0, c, s of 0 from here equal to 4, so 4 plus 2 over 3 equals c. So c equal, this will be 12 over 3, 12 plus 4, 14 over 3. Now s of t itself will be 2 over 3 dq minus 2 over 3 t plus 1, 3 over 2 plus t plus 14 over 3. They ask us to find s of 5 here, so we write s of 5 equal 2 over 3, 5 cubed minus 2 over 3. 5 plus 1 will be 6, 3 over 2 plus 5 plus 14 over 3. I have the calculator in my hand, but I'm not fast in this, and usually I will say do it by yourself, but since it's in my hand, I can find it. 2 over 3 and 6 to the power 5 3/2 and plus 5 plus 14 divide 3. I hope I did it without mistake. Yeah, it's math error. I hate using the calculator. Why we got math error? I don't know. We should maybe put brackets for the 6 because maybe this one it was the problem. Let me try again. No, it's still math error. Okay, this one we can find it, this one we can find it, this one, this one, this one. I don't know why I keep getting math error. I don't know really. It's maybe we need to add one more brackets here and here. Let me try now. No, the calculator used to do that, so you can do it by yourself and put the answer here. There's nothing error, but I put it all of it in one time in the calculator and I got math error. Okay, no need for calculator. This will be 2 divide 3. This will be 1, 2, 5 minus. I think this is the problem was 6 to the power. It's the power of it 3/2. The answer is 14, 2/3, 14.6969 plus 5 plus the last number 14 divided by 3. It's like 4.6 repeated. You can now write the final answer here. Okay, that was the last. This will be the last video for Calculus 1. So my new videos will be inshallah regarding Calculus 2, or maybe I will make one more video for final exam or something for final exam.